Hey, it's Dr. Rich again. Let's take a few minutes to look at hierarchical multiple regression and the little triggers and whatnots to click in order to get that. So we're still talking about multiple regression at the end of the day. So I'm just going to go right back into my analyze and regression and linear. I've placed my dependent variable up here, customer house score, CHS, and then a few of the variables down here. I could even select a few more variables if I wanted to. Demerits is not a good idea, so I'll do something else if I can find something. Give me just a moment. Probably should have done this before I started the video. All right, fine, we'll just leave it as is. So the default method is enter, but what we can do is a stepwise, and that will give us adding each of these variables successively or stepwise and build several different models. So you'll see kind of how this all works out. And the order that I list these is also important. So it'll start with the top and then work its way down. So I'll click statistics. It's the same thing here. Here's where this R-squared change will come in handy. Pardon me. Make sure you have these plots down, histogram, normal, PP plot. Yeah, options, you can leave those default, style, yeah, who cares, doesn't matter there. Then if we click OK, we'll get some results. And it built 3 different models, interestingly enough. So you can see the model summary down here for the 3 different models. So the first model is, you can see here, model 1 significance is statistically significant model, so that's good. I have a little tiny b there, I don't know if you can see it. And it says B predictors, so the only predictor was N participants. So then you can see in model 2, it added the next variable. And then model 3, it added that final variable to the last 2. So we can see really the difference here. With a single independent variable, my R-squared is only 13.4%. And it only goes up, a little bit to about 17.6%. And then adding that final variable didn't really add much more. So going from 13.4% to 18.2, a little bit of an improvement. I'm not gonna bring my stakeholders this model. It's not a great model at all, really, because of the R-squared. So you can really observe the little bit of amount of change in R-squared as we build the successive models. So that's really the power of hierarchical multiple regression, is this bit right there. And of course you'll get the 3 models down here with all the coefficients. Apparently this is a statistically significant model, which is good, but I am definitely not happy with the R-squared. So that's something to consider. The literature reports different information about what a quote-unquote good R-squared is. So I'll let you read up on that when you need to, because that'll be an important thing to think about if you happen to use regression in your own study. Using CHS, I've shown you this before. It's relatively normal, and you can also tell that by the standardized residual plot, the PP plot here. Okay, that's all for now.